Chapter 18, Worksheets 50, 51, and 52, Types of Chemical Bonds, Number of Atoms in a Formula, and Gram Formula Mass. And I'll explain each one as we get to that page. But first, let's talk about the two types of chemical bonds that we're dealing with in this assignment and mainly throughout the chapter. First one is called ionic. And notice right here, that's anytime we have a metal combining with a nonmetal. For example, sodium, element number 11, which will give away its one valence electron and end up with an electric charge of +1. That will very easily combine with chlorine, element number 17, that will take on that extra valence electron to give itself 8 valence electrons, meaning that's going to be a -1 charge. Now remember, opposite charges attract, so these two elements will stick together with a very strong electrostatic force. Very, very difficult bond to break. And then we end up with the formula that you all know already, sodium chloride. We call that an ionic bond. All right, next, we look at covalent bond. Covalent bond is anytime two or more nonmetals combine, but they don't transfer, they don't give away or take electrons, they share. And we see H2O, number 3, so I'll go ahead and talk about that one for a moment. What we have, look at the picture where you see 4 hydrogens surrounding 1 carbon, and you see pairs of shared electrons. Let's say, since the carbon one's shaded a little more blue, that each blue dot is the carbon electron and each red dot is the hydrogen electron. And you notice that they're both holding on to both those electrons. So carbon now has 8 valence electrons, and each hydrogen will have 2 valence electrons. And remember, since hydrogen has only the one energy level, it is full. So by sharing, we have what we call a covalent bond, and these elements are going to share those electrons. They're both nonmetals. Now look at question 3, H2O. Well, at least for this page, all we really have to do is identify if we have metals or nonmetals. We have 2 nonmetals here, so go ahead and write covalent for question number 3. All right, we'll clear that off and we'll talk about both. And look for the words polyatomic ions right there. If we see these things, and I'll tell you what they are in just a moment, then we're going to answer both. Now, you look at question 4, barium sulfate. SO4 is called sulfate. That is a covalent bond between 2 nonmetals, S and O, sulfur and oxygen. And then for it to combine with barium, that's a metal, we're going to have a transfer of electrons. And as we study through Chapter 18's notes and other practice problems, we'll get more familiar with each kind, the ionic and the covalent. But since you have an ionic bond and a covalent bond, now look also how I help you identify those. I put all the polyatomic ions in parentheses. So pretty much wherever you see parentheses, you're going to have a covalent bond then combined with a metal to give us an ionic bond. So for number 4, go ahead and write both, and go ahead and do that for number 7 also, which is showing up on your screen. So number 7 is also both because CO3 is called carbonate, that's carbon and oxygen, 2 nonmetals, then combining with sodium, a metal. So if you see parentheses, think there may be both bonds happening. All right, now let's clear this off and start over. I'm going to do the first 7 that you see on your screen and then leave the rest of the page for you to try, and then we'll move on to page 51. All right, so number 1 says calcium chloride. First question to ask, do you see a metal? And in calcium we do. So we have a metal, calcium, and a nonmetal, chlorine. Now remember, metals on your periodic table are to the left of the staircase. And to the right, those are your nonmetals. Now hydrogen is really a nonmetal, but sometimes it thinks it's a metal. So we'll talk about hydrogen also as we get to a couple of other examples. So since calcium and chlorine is a metal with a nonmetal, we're going to have an ionic bond. So go ahead and write that down for number 1. Now, from what is showing, where else do we see a metal with a nonmetal? Look at number 5. Potassium is a metal. Oxygen is a nonmetal. Since we have one of each, we will put ionic bond for number 5. Do you see any more showing that is simply one metal with one nonmetal? Look at number 6. Sodium, metal, fluorine, nonmetal. So that also is an ionic bond. All right, now look at number 2. Carbon dioxide, CO2. Both carbon and oxygen are nonmetals. Since we have 2 or more nonmetals, we will have a covalent bond. We talked about water a little while ago. 2 hydrogens, 1 oxygen, both nonmetals. We have a covalent bond. We also talked about questions 4 and 7 just a little while ago. Sulfate, SO4, that's a covalent bond of 2 nonmetals, then combining with barium, which is a metal. So we will put both. Number 7, we call this sodium carbonate. CO3 is called carbonate. So we have a covalent bond of carbon and oxygen, then combining with a metal, sodium. So we do have both bonds here in sodium carbonate. All right, in just a moment, I'll clear this off and scroll down because I want to show you something else about hydrogen. But look again, the ionic bonds are metals with nonmetals, and for what we're doing, we'll have exactly 1 metal and 1 nonmetal make up an ionic bond. 2 or more nonmetals, like right here, CO2, that will be covalent, and if we do have one of each, we're going to answer both. Now, some on the bottom of the page will also be both. Look for parentheses. It's not a 100% guarantee, but it's a very good visual clue. I'm going to clear this off and scroll down and talk about question 13. And you'll notice question 13 has hydrogen. Now let me rewrite H2O up here. This is not the answer to number 11. This is what's tricky about hydrogen, because in this case you see hydrogen and oxygen and we answered covalent bond. But if you look at question 13, and I can understand it gets a little hard to tell. Now we have hydrogen chloride, hydrogen and chlorine, also called hydrochloric acid. That's your stomach acid that digests food. In this case, we're going to have an ionic bond because remember I said a few minutes ago, hydrogen will sometimes act like a metal and sometimes like a nonmetal, and just looking at the formulas when you're not used to it, it's hard to tell. But hydrogen is going to give away its 1 electron and be positive. Chlorine will take that and be negative. So for 13, go ahead and answer ionic bond. All right, let me get this out of the way here up above. And look for parentheses once again and answer both where you see those. So I'm not going to write any more on here. I want you to try to finish the rest of this yourself. In parentheses is a covalent bond, and then, like number 17, PO4 is called phosphate, will then combine with aluminum. And notice the metal will always be written first. So I will want you to try the rest of this page on your own. Okay, I'm going to clear this off and now scroll down to page 51. Finding the number of atoms in the formula. This is one of those that I like to say is a lot easier than it looks. All we're doing is counting how many atoms make up the formula. Basically, if you know how to count, you'll figure this out, because all I'm doing is counting. So number 1, sodium chloride. In an ionic bond especially, we change the last 3 letters of the name to IDE, and that's why we call it sodium chloride. Well, for sodium, again, we're simply counting how many atoms there are. So sodium has 1, chlorine has 1, and all I have to do is add those together, 1 plus 1 is 2. All right, so let's look for one now that has a subscript, a number below the atom's symbol, number 12. We have potassium, manganese, and oxygen. I don't know the name of this one, but that's okay. All we're doing is figuring out the number of atoms. For potassium, you see there is 1. For manganese, Mn is manganese, easy to mix up with magnesium, but Mn is element number 25, manganese. We have one of those. Now oxygen, you see the 4 right there. So how many oxygen atoms are in this formula? 4. So again, just add those up and we get a total of 6. All right, let's look for another one that has a subscript. Number 4, calcium chloride. 1 calcium, can you see that there are 2 chlorines? Gives us a total of 3. All right, number 13, H2O2. This is hydrogen peroxide. It's not the same thing as water. That little bitty 2 at the end of the O, that turns a very safe substance that we have to live into a very deadly poison. So 1 extra oxygen atom really changes the makeup of the compound. But you see H2O2, so there are 2 hydrogens and 2 oxygens, giving this molecule a total of 4 atoms. Now we have to go to the ones that have parentheses. And sometimes you have numbers inside the parentheses and outside the parentheses. Well, remember, just like in math, the parentheses indicate distributive property. So if I had something like 4 times 2x plus 6, I would multiply the numbers outside and inside, go up here for a little more room, to give us 8x plus 24. That's distributive property, just like you're already familiar with doing in math. All right, so let me get this out of the way so you can see the directions better. So let's look at number 2, H2SO4 in parentheses. SO4 is called sulfate, so this is called hydrogen sulfate, also called sulfuric acid. All right, again, the parentheses, well, we don't have a number on the outside this time, so we don't have to worry about it. So for hydrogen, we have 2. For sulfur, just 1. Now, just like in math, even though there's parentheses, that 4 is inside, so it goes on only the oxygen, kind of like we had a moment ago. Had something like this up there. That 2 goes with only the X, not the 6, but the 4 on the outside goes with both the 2 and the 6. Well, that oxygen has the 4, but nothing else does. So 4 here. So again, I'm going to erase that and start that one over because I interrupted to tell you something else. So hydrogen 2, sulfur 1, oxygen has 4, and then again, just add those up. 2 plus 1 is 3, plus 4 is 7. And number 3, same thing. Potassium nitrate, 1 potassium, 1 nitrogen, and 3 oxygens. And so 5 total atoms. All right, same idea with number 14. 3 hydrogens plus 1 phosphorus plus 4 oxygens for a total of 8 atoms. Now though, number 11, little bit different. Only because it has an extra subscript. It has a number on the outside of the parentheses. Well, remember, just like in math, it's outside times everything inside. So what we're going to do is this. The copper, obvious, 1. All right, so it took care of the copper. The nitrogen, 1 inside, but realize something. That NO3 with a 2 on the outside means this. It means NO3 is written twice. So how many N's are there? And how many O's are there? 3 on the first one, 3 on the second one would be 6. Right? So all I'm going to do is distributive property like you already know how to do. So remember, an unwritten number is 1, so 1 N twice, that's 2 nitrogens. Oxygen is 3 times 2, 3 inside twice, and that is 6. So 1 plus 2 plus 6, that's a total of 9 atoms in what we call carbon Nitrate. All right, I'm going to pause for a moment. You can pause the video too and take a look at those, then we'll do a few more. All right, I'm going to clear all this off so I can scroll down and look at a couple more. Of course, I don't want to take all the fun away from you, so I'll do a couple more and then let you try some on your own. All right, let's look at number 5. C2H6, 2 carbons, plus 6 hydrogens, a total of 8 atoms. All right, I'll go ahead and try number 15. NH4, 3, PO4. This is called Ammonium Phosphate. Now again, just like in math, it's distributive property. Nitrogen, 1 times 3 is 3. Hydrogen, 4 inside, written 3 times, that is 12 hydrogens. Go to phosphate. Now realize that 3 is done. It goes with only the formula in front. So PO4 doesn't have a 3 on it. So now for phosphorus, we have 1 of those, and we're going to add those together, and oxygen has 4, and that is a total of 20 atoms. Okay, I'm going to try 2 more with you, and then let you handle the rest of those. Number 8, calcium phosphate. How many calciums? You see the little bitty 3, so there are 3 calciums. All right, that 2 right here after phosphate, remember calcium's done, it's not in the parentheses, so it doesn't get the 2, just like in algebra. Phosphorus, P, 2 of those, so 2 phosphorus, and remember it's 4 times 2, not plus, so there are 8 oxygens. That means we have a total of 13 atoms. All right, last one I'm going to do for you on this page, then you try the rest. Number 18. Magnesium, carbon, hydrogen, and oxygen. All right, magnesium's all by itself. It doesn't have a subscript, and it's not inside the parentheses, so it doesn't get this 2 right here. So 1 magnesium. Carbon is C2 times 2, so 4 carbons. Hydrogen is H3 times 2, so that's 6. And oxygen is O2 times 2, so that's 4. Simply add those together, and we get 15. All right, pause it, make sure you have these down, and save the rest for you to try in just a bit. Okay, page 52, gram formula mass. For this page, you are going to want to look at your periodic table. So if you haven't already done so, pause here and take out your periodic table because you're going to look up the mass of each atom. So you see number 1, sodium chloride. Now you notice that we have the same 20 formulas that we just had on the last page. That's to help make sure you know how many atoms are in each formula. But this time we're talking about the mass of the atom. So you're going to look for the decimal, and we're going to round that decimal off to the whole number. It's called gram for a reason. If we have a specific number of these molecules, then we will measure the mass of those molecules in what we call grams, which you're already familiar with. I'll get more into that at another time. Right now we're just looking up how to find the gram formula mass. All right, so I'm going to go ahead and highlight mass once again. All right, now for sodium. This time we do want to know how many there are, but we need to know the mass. So find sodium, element number 11, round that decimal to the whole number. So you see the mass of sodium will round off to 23. Chlorine, element number 17, has an atomic mass rounded off to 35. Use the regular rules for rounding, whether or not to go up or down, and simply add those together. In case you heard the beeps and the noise, those are big trucks driving by. 23 plus 35, now all we have to do is add those together, and we get 58. So one molecule of sodium chloride has an atomic mass rounded off to about 58. So there are a total of 58 protons plus neutrons together. Remember, the atomic mass comes from adding the protons plus the neutrons. And if we had a specific number of these molecules called a mole, I've told you that before, 6.022 times 10 to the 23rd, that many molecules would have a mass of 58 grams, and that's why we call it gram formula mass. All right, number 2. I realize I misnumbered, but oh well, that's the way it goes. So number 2, potassium nitrate, right here, the K plus the NO3. So look up potassium, element number 19, and notice that its mass is 39, rounded off, of course. There's no subscript on the outside of the nitrate, so we don't have to multiply those things just yet. When there is a subscript, like you'll see on the next one we'll do, that one there, I'll tell you what to do when we get to it. So nitrogen has a mass of 14. Oxygen has a mass of 16, but notice there are 3 of those. So all I'm doing really is I'm changing the letter into a number, just like when we did word problems. Change the words into numbers and then do the math. So now I have 39 plus 14. Oxygen's mass is 16, but we have 3 of those. So now all I have to do is do the math. 39 plus 14 plus 16 times 3 is 48. Remember, order of operations. Add those together, we get 101. And that's really all there is to it. All right, now I highlighted number 11 for a reason. Number 11, copper nitrate, because it has the 2 on the outside. So we have to remember that as we work this. All right, find copper, element 29, and round off. That mass is 64 for copper. Nitrogen, that mass is 14, but you need to notice there are 2 of those nitrogens. So it's 14 times 2. It's kind of like this. You're going to the store, you're buying something, and you're buying 2 of those. The price is $14, and you're buying 2 of those. So 14 times 2. So now you go and you buy oxygen, but how many are you buying? 3 times 2. So the mass of oxygen is 16 times 6, because you're buying 6 total oxygens. All right, let me uncover that so you can see what I'm talking about. It's O3, but remember it's O3 twice, so it's really O6. So now, go ahead and do the math. This is 28. 16 times 6 is 96. So if I add all this together, I get 188. So all I'm doing is changing the letters into the numbers, and the numbers are the mass, and then I'm doing elementary school math. Multiply first, then add everything up. All right, let me make a little space here by clearing this row here. Let's do number 12, potassium, manganese, and oxygen. Potassium's mass is 39. Manganese is element number 25. It has a mass of 55. Oxygen, its mass is 16, and remember, you're buying 4 of those. So now just do the math. 39 plus 55 plus, this will be 64, and I get a total of 158. All right, let's do number 13, then we'll scroll down and do a couple more, and then of course I'm going to leave a few for you to try yourself. Hydrogen, and when you see these over and over and over again, you might start to memorize. Hydrogen's mass is 1, and I'm buying 2 of those. Oxygen's mass is 16, and I'm buying 2 of those. So 2 plus 32 is 34. All right, I'll go ahead and do this last one that's showing here. Hydrogen sulfate. Hydrogen's mass is 1, and there are 2 of those. Sulfur has a mass of 32. There's only 1. That 4 is on the inside, so it's on the oxygen only, not the sulfur. Oxygen is 16, and there are 4 of those. So hydrogen's 1 twice, sulfur is 32 once, oxygen is 16 4 times. All that will give us a total of 98. All right, I'm about to clear this off, scroll down, do a couple more, and then leave the rest for you to try yourself. All right, let's scroll down, and I'll pick a couple more to do. I will start with one that looks a little bit easier this time. Number 19, Hg2Cl2, mercury chloride. Mercury is element number 80, so look at your periodic table. Mercury's mass rounds off to 201, and there are 2 of those. Chlorine, 35, and there are 2 of those. So what we have now, 201 times 2 plus 35 times 2, that is 402 plus 70 for a total of 472. It's gram formula mass, so we really would put grams, but right now I just want you used to doing the numbers. I'll pick a couple more. Number 8, calcium phosphate. Calcium, element number 20, with a mass of 40. All right, but remember, you're buying 3 of those. Phosphorus, element 15, has a mass of 31, but notice that 2 goes with both the P and the O, so it's 31 twice. Oxygen has a mass of 16, but notice here, it's O4 twice, so it's O4, O4. That means we have a total of 8 oxygens. Just go ahead and do all the math on that one now, and you will get a total of 310. I will do 2 more and leave the rest for you to try. Number 16, iron oxide. Actually, it's called iron 3 oxide. I'll tell you why another time. And that is the scientific name for something we see all the time called rust. All right, so what is the gram formula mass of rust, or iron 3 oxide? Iron is element number 26 with a mass of 56, but there are 2 of those. Oxygen has a mass of 16, and there are 3 of those. So 112 plus 48 is a total of 160. Okay, last one, and then you get to try the rest all by yourself. Aluminum. Question number 9. Aluminum is element 13 with a mass of 27, but notice there are 2 of those. Sulfur in the parentheses with a 3 on the outside. So sulfur is 32 times 3. Oxygen has a mass of 16 times how many? Notice it's 4 times 3. That's 12. All right, add all this together. 27 plus 2 is 54. 32 plus 3 is 96. 16 times 12 is 128. So all that equals 342. And that is how you work gram formula mass. So I'd like you to try to finish the rest of these 3 pages on your own. All right, we'll catch you next time. Thank you.